Welcome to another learning series with the Black STEM Project. This series is Network Fundamentals, TCP/IP Part 1 with the Black STEM Project. In this session, we'll provide an overview of the TCP/IP model. We'll discuss physical addressing and the physical link between nodes, as well as logical addressing and the logical link between nodes. Prior to watching this session, you should have already reviewed what is a network, as well as the OSI model. Please see the links in the descriptions below. A network allows two or more nodes to communicate over a shared medium. That medium could be copper cables such as Cat5, Cat6, optical cables, as well as radio signals over the wireless. The OSI model was created out of a need to allow systems from different manufacturers to communicate. It used to be that each manufacturer had their own networking protocol. So systems from one manufacturer would not be able to talk to systems to another manufacturer. The OSI model was designed as a reference guide that describes how systems from different manufacturers can communicate with each other. The Transmission Control Protocol Internet Protocol, TCP/IP, is the shared language or network protocol of modern systems. The TCP/IP model maps to the OSI model. The network access layer of the TCP/IP model, sometimes called the network interface layer, maps to layers 1 and 2 of the OSI model. Switches, physical cables, network cards, etc. all exist at the network access layer. The internet layer of the TCP/IP model maps to layer 3 of the OSI model. IP addressing, as well as routers, reside in the internet layer. The TCP/IP host-to-host layer maps to layer 4, or the transport layer of the OSI model. The host-to-host layer contains protocols that controls how traffic is communicated over the logical link between nodes. The application layer of the TCP/IP model maps to layers 5, 6, and 7 of the OSI model. The network access layer of the TCP/IP model covers layers 1 and 2 of the OSI model. At the network access layer, we have the physical layer, protocols related to the physical medium on top of which TCP/IP communicates, the electrical and optical protocols, protocols that describe the form factor of the network interface card. The network access layer also includes the data link layer. The data link layer has protocols related to how the medium is accessed, shared, and how you identify devices on the network using a physical address. Each network card on a node, including wireless, Bluetooth, and Ethernet, has a physical address that uniquely identifies that network interface card on the shared medium. The physical address is also called the MAC address. MAC stands for Media Access Control. The Internet Protocol, or Layer 3. The Internet Protocol is responsible for logical addressing between nodes, known as an IP address. An IP address is made up of 4 octets. Note that 4 octets for an IP address is specific to IP version 4. There are also IP version 6 addresses. We will cover IP addresses in detail in another session. For this session, it's important for us to understand that an IP address is the logical address of each system. An IP address is made up of a network ID and a host ID. For example, Consider 123 Main Street. With the U.S. mail system, we have the concept of zip codes. So the zip code of 30062 can be compared to the network ID, and 123 Main Street would be the host ID, uniquely identifying 123 Main Street and zip code 30062 from all other 123 Main Streets throughout the United States. It's a loose analogy, but hopefully it helps you to distinguish between network ID and host ID. We will go into IP addressing, network ID, host ID, and subnetting in another session. Layer 3 is also responsible for routing data across logical network paths. Each network interface card, wireless, as well as Ethernet, has a unique IP address. The IP address is unique for your medium. In this instance, 10.1.1 is the network ID for the wireless network, and .10 is the host ID for the IP address for the node on the left, and .20 is the unique host ID for the node on the right. And for the Ethernet, 10.3.1 is the network ID for the node on the left, 10 is the unique host ID for the node on the left, and 20 is the unique host ID for the node on the right. The host-to-host, or Layer 4, contains protocols that control the Internet, or Layer 3 layer. The transmission control protocol, considered reliable, resides here, and the user datagram protocol, considered unreliable, resides here. We will go into details of TCP and UDP in another session. The host-to-host Layer 4 also controls traffic on the logical link, an end-to-end connection between two nodes. Layers 1 and 2 and layers 3 and 4 both generally serve the same purpose. They convey data from a source address to a destination address. Layer 3 and 4 are responsible for the logical link between the IP addresses, and layers 1 and 2 are responsible for the physical link. There's another protocol called Address Resolution Protocol, or ARP, that is responsible for resolving the logical IP address to the physical MAC address. We'll discuss ARP in another session. Summary. Let's review what we learned in TCP/IP Part 1. We learned that TCP/IP became the shared language for open communications between systems. All modern systems use TCP/IP. We learned that TCP/IP model can be mapped to the OSI model. We learned that the network access layer, layers 1 and 2 of the OSI model, are responsible for protocols related to the medium, protocols to control access to the medium, as well as physical identification or physical addressing known as the MAC address. The Internet layer, or Layer 3, is responsible for logical addressing. Internet protocol or IP addresses reside at this layer. Layer 3, or the Internet layer, is also responsible for routing data across logical network paths. The host-to-host layer, or Layer 4, has protocols, specifically TCP and UDP, to control traffic across a logical link. It creates a logical point-to-point connection between nodes. The TCP/IP application layer maps to layers 5, 6, and 7 of the OSI model. Layers 3 and 4 convey data from source address to destination address over a logical link. Layers 1 and 2 convey data from source address to destination address over a physical link. We hope that you've enjoyed this learning series. Please subscribe, like, and comment. Thank you.